Good. That's the leftover line from last time. I love it. So let's see. What did you guys get for your line?
Yes.
I got this. Is this?
That's what I got too.
Yeah, I got it.
Yep.
My R value is 0.738 roughly. And that is bigger than the 0.456 I just told you a minute ago that had to be. But now I'm going to be, all right. I try to make it really clear because I don't want you worrying about what adjective to use. Because this would be a difficult adjective to figure out. It definitely is greater than 0.456, so there is correlation. Is it strong? No, not really. Is it weak? No.
No.
It's decent. So I don't want you sitting there going like you're trying to figure out how to describe a wine or something. It's going hints of no. So mine normally I'm going to make it like 0.9 or in this case 0.5 or something really clear. They'd be weak or strong. At the same time, I do like to use real life data. So sometimes I'll use like offensive and defensive yards for football teams and who's got the best records. And then we figure out what's a better correlation. Is it offense or defense? Which one predicts wins better? And 1 year it was defense, and the next year is offense. It kind of goes up and down. I do it with basketball sometimes too, just to remind people about what their records are.
Let's take a shot at it.
You can take that however you want to. So right here, for this one, and again, hopefully you guys understand what I just said. You're never going to have to worry. Here I'd say decent or middling or whatever, like middle of the road kind of word you want to use. But on the test, it's going to be really clear. It's going to be like 0.9 something, strong. And so decent, and I left out something important. I wish I could say I did it on purpose, but I didn't. Decent, what kind of correlation? Decent positive correlation.
For what?
So decent positive correlation.
For what?
I'm going to assume that's not directed towards me.
Oh, that's what you just told us. Yeah. So like, see, that's what you just told us. So on the test, you're going to have R equals 0.9, and then he's going to give you that it has to be greater than 0.5 to be strong.
All right.
So I'll show you. Are you here?
I showed you earlier is this little table. I'm going to put it on a test. Or it has to be greater than whatever to show correlation.
And so that's why it's decent.
It's all right. Why is there correlation? Because it beat the test. It's bigger than 0.456. That's why there's correlation. Why isn't it strong or weak? Because it's not 0.9. It's not like barely above 0.45. It's right in the middle. So it's middling, or whatever kind of word you want to use. I'm not going to do that to you in a test. I'm not going to have you going, sort of strong. No, it's going to be definitely one or definitely the other one. Yes.
Is there a mathematical test you do to test like whether it's strong or not?
Total. There's the population parameter is called rho. It's the Greek letter R. It's rho. So there's a whole hypothesis test you could go through. I think this book gets into it a little bit. We're not going to do that.
You know what the test is called?
Hypothesis test for correlation.
How do you come up with the
So again, if you're paying attention earlier, I showed you a chart that went by sample size to tell you what the benchmark was for R. For a sample of size 19, it was 0.456. So it's exactly like saying Z star has to be bigger than 2.576 to show evidence. Same idea. R has to be bigger than 0.456 to show evidence. There is evidence. Is it strong? No. Is it weak? No. Is it in the middle? Okay. Second. So again, it's like that little dividing line, but I'm going to make it clear one or the other. It's going to be like 0.95 versus 0.48. 0.48 would be correlation, but it would be really weak because it just barely got over that. So that means the points would be going up, but they would be kind of spread out more further away from the line. Yes? All right. I'm not going to say it a fourth time. Okay.
Never gonna be.
All right, so what's this look like? Let me write down the equation. A number doesn't go here, okay? This is the equation. So this will be 0.657x plus 70.97, something like that.
So they don't have to be random.
Doesn't matter. No. Yes?
He wants to know if it's alright if we put the B first and then the A and X, plus A and X.
I don't care. So when you first take algebra, an easy way to confuse students is to say y equals 7 plus 2x. What's the slope? And everyone goes, 7, it's the first number I see. But the slope is the number that's in front of the x. So as long as that's true, I don't care how you write the damn thing. Cool. So now I can put in here y equals, I can put in my equation for this one. 0.657x. 70.97. And now if I graph it. Yes, ma'am.
On the test, do you want to round points to the slope and decimal point? Or
Sure, that's fine.
Whatever you want.
I love you guys so much. I've gotten you so freaked out about rounding. Remember what covers your ass? 3 places, 4 places, something like that. You'll be fine.
Yeah, except when I got 3 places, I didn't.
Again, this is an estimate. So yeah, a couple places is fine. That's because I was really clear earlier this semester about standard deviation and probabilities. For this, I'm telling you, it's not that crazy. It's not. There's no thing that covers everything. Okay. All right. I love it. So I'm going to mark you off because you make that 70 point or 71. No, that's what I'm telling you right now. Okay. That's what you got to be able to come up and show me. This is going to be a part of the test where I give you the data and I say, now come up and show me your calculator. Show me the scatter plot and the line of best fit.
Have you went 40 points?
What? Are you making a suggestion? You're writing it down. 40 points.
Watch your video.
Okay.
Wait, what did you write down?
So Musa, I'll make yours worth 40 points. No! It's going to be one piece of a problem. So I understand students sometimes look at it like, well, I'm not even going to study that because there's only one problem. It's up to you. Okay. Now, this data was about number of hours studied versus the grade you're going to make. So let's do 2 things. Let's make 2 predictions. Let me see if you guys can figure out how to make a prediction. What if I see how 15 hours for a student came out to be an 85 on the test? So let's see. We got a decent correlation. It's not really strong. So that what that means is if I find out what the line of best fit predicts for 15, it doesn't have to be really close to 85, but it should be in the ballpark. It's not a very strong correlation. If R was 0.99, I put in an X, it's going to come out with a Y almost exactly the same as what actually happened. That means all the points line up really tight to the line. So how do I put 15 in? How do I put 15? Does everybody see what I'm pointing at? The 15-hour studied is 85 on the test. You guys see that? 85 grade. How do I put that 15 into my equation of the line of best fit? X, thank you. It's XY table. So if you throw 15 in for X and do it, see what you get. You got your equation right there.
What are the numbers?
And I love the people who are like, you don't need algebra for stats. Well, they're stupid.
Because your
That's where we're going right now, man.
your thing doesn't cut out right. One of your numbers is wrong.
That's all we're doing right now is throwing a 15 in for X. Which come out to like 81 almost.
You picked 15 just like randomly, or does that have to be?
I did pick 15 randomly. But Are you going to pick something? No. I'm going to pick something and make a question out of it. So the question I'm making right now is, if you study for 15 hours, what does your analysis predict your grade should be? So what do we get? 80.8. So again, are we surprised that it's 80.8 and the actual, for the student who did study 15, is 85? I'm not surprised. In fact, you can't always do what I'm about to say, but look at the 16 hours, what they make. Yeah. So this is an averaging. Remember that line of best fit is an averaging process. So any individual thing I kind of try to check is not going to come out exactly right because it's an averaging amongst everybody. But the closer R is to 1 or -1, the better that prediction has to be. That's the idea. So that goes along with, do I trust the line to make predictions? This one, yes. The prediction won't be perfect, but they'll be better than just guessing the average grade. I like it. So that's that last question. If you use the line of best fit to make a prediction, would you trust that prediction? Yes. I know it's not perfect, but I trust it to be better than anything else I got. Yes, because R is a decent amount above the minimum required. If R was 0.9, I'd be like, hell yeah, I trust the hell out of this thing. Okay. So, what I want you guys to do, the last thing you have to do on this sheet, you're going to love this piece. Let me help you out in the first couple steps. I want you to do what we just did. Well, what that means is really understanding what this picture is showing you. What is that? What is that? What does this mean? What is that? What is that?
0, 19.
0?
19.
20.
20.
0, 20. Keep going. And then you got your L1, you got your L2. You could do the linear regression, get your line of best fit, get your R, do everything.